Okay, so a little hint for 84. You're going to go through your rules here. Sorry for the, I should say, spaz alert or seizure alert. I think it said sine something and, tangent. You're going to follow the rules, And when you write out this and you simplify it, the next thing you might want to do is multiply everything by cosine x. That might simplify things for you. Okay, so finding the exact value of an expression involving inverse trigonometric functions. I can almost say that. Find the exact value of sine of this angle, right? This angle, because it's tangent minus 1. So whatever that is, it's an angle. This thing inside here, that's an angle. And it's this angle down here, right? Because, take a look with me. The opposite is 1. Well, there's 1. And the adjacent is 2. Oh, yeah, there's 2. Okay, so that's the angle right there. Do I care what the angle is? No, I do not care what the angle is. I'm just going to use it. I'm just going to take the sine of that angle. So when I take the sine of this angle, it's 1 over the square root of 5, and I get that. Okay. So don't care about the angle. I don't suppose I care about their discussion too much, but it is true and it is nice. And this says there's going to be some angle. So it implies there's some triangle with opposite side 1 and hypotenuse 2, and I can find the adjacent side, and I'm going to need it because I'm talking about the cosine. Okay, that's fine. And then, once I have that angle, I can say the square root of 2, there it is, over the hypotenuse, there it is. Okay, you've done this before. This is a different source here for this, but you've seen this before. This angle here, cosine minus 1, okay. There's some angle, oh, and it's negative, so we'll put it over here in quadrant 2, yeah. And the adjacent will be 1, and the hypotenuse, yeah, that's right there. And I can find the opposite for when I'm going to need it for the tangent, the opposite. So I don't know. I'm circling, I'm pointing, but you get the idea. When I take the tangent, it's going to be the opposite. There it is. Over the adjacent, there it is, and it's negative, and so I get my answer. Okay, so I don't care what the angle is at all, and I don't care down here either. I just know that there's some triangle implied here, and the triangle implied is opposite over adjacent, so it's positive. I guess I'll put it in quadrant 1. Everything in quadrant 1 is positive, so I'll say the opposite is 4 and the adjacent is 3. Looks like I got it backwards the way I drew it, but you'll bear with me, I hope. So there's some angle here. We'll call it theta. And that describes it. So then when I take the sine of that angle, because this right here is theta, whatever it is, I'm going to need the hypotenuse, so I guess I better get busy finding the hypotenuse. C is equal to 4 squared plus 3 squared. Oh, I guess I knew that was 5 already. 3, 4, 5, right? But anyway, the square root of 25 equals 5. Okay, fine. So it's 5. So when I say the sine of this angle, well, what's the sine of theta? The sine of theta is 4 over 5. The end. That wasn't bad, was it?